Alright, Griffins, let's do another video. I have about 15 minutes till you're going to hear an ear-piercing bell, which is going to release students for today, and so that's when I'm going to stop. Alright, so last time we did the first 14, so now we're just going to go starting with number 15. Chris multiplies the first 6 positive prime numbers. You need to be able to zip through that and write them down and be looking at them in no time at all. How many zeros follow the last non-zero digit of the product? So if you start multiplying these things out, which you cannot do, you don't have time to waste on that. You need to say, how do I make things that end in 0? And that is with multiplying 2s and 5s. That's how you get 10s. So if I look right here, I've got a 2 and a 5, so that's going to make a factor of 10. So all these other guys do not have any 2s or 5s, because if I had another 2 and another 5 as a factor embedded within these other 4, I would make another 10, and 10 times 10 would be 100, which means that it would end in 2 zeros. But right now, these numbers right here will not give me another 2 and 5 to make a factor of 10. That's it. So no matter what these other 4 are, I'm going to multiply it by 10, and that means that the number, my product, will end with 1 0. Alrighty. Let's go over here. 16. Now again, there's a lot of unit conversion problems in here. I noticed on the previous example we did some unit conversions. Go back and look at number 6. We did a unit conversion. Number 8. That seems to be a real big one because we're going to do one on 16. So here we go. Carmichael's favorite race car driver, 10 laps in 10 minutes. So 10 laps, 10 minutes. Okay. Now we know that 10 over 10 is 1. So really it's 1 lap for every 1 minute if you want to get a head start on the problem. Alright. So now we have to look at our answer. It says miles per hour. Right now we're in laps per minute. So let's get out of minutes by multiplying by a unit fraction. 60 minutes is 1 hour. Alright, so now we can cancel the minutes label. So now we're in laps per hour. So we're close. So now we're going to come over here and use this. The track is 2.5 miles long for every 1 lap. So now we can cancel out of the lap unit. So now we have miles per hour, which is what we want. So now basically this is 1, 1, 1, 1. All we got to do is take 60 times 2.5, and you got to be able to do that in your head. 2 times 60 is 120. Half of 60 is 30, so 120 plus 30. You need to be able to get 150 out of that rather quickly. Now, number 7 is a quadratic problem. And a quadratic problem is something that is explored extensively in the Algebra 1 course. You have not had this yet. So, I am not going to try to teach a subject or a topic that takes weeks to develop in a video right now. I am going to tell you how we can get our answers quickly, and either Mr. Shell or myself will explain quadratics at a future date in your lives. So here we go. We want the value of A, which is this guy right here. Okay? Solutions make things true. Okay, so these two guys right here, the 2 and the 7, when we know what A is, will make this equation equal to 0, as stated. Am I worried about that right now? No, because like I said, I haven't taught quadratics to you yet, or an algebra teacher hasn't taught you. But because x makes the problem true, pick one or the other, not both. I'm going to pick the smaller one because smaller numbers are easier to work with. So I'm going to come over here, and everywhere I see an x, I'm going to plug in a 2. I'm going to keep the a times, that's multiplication, a times 2, because x is 2, plus 14 is equal to 0. I'm not going to even mess with the 7. Okay? If it's true for both, just pick one of them. So everywhere that I saw an x, I put in the solution. Now you notice I went from an equation with 2 letters, a and x. Now I only have an equation with a, which, oh my goodness, that's what they're trying to solve for. So let's just crunch numbers. 2 squared is 4. 2 times a is 2a, plus 14. This should start looking familiar. You can combine the 4 and 14, and you should be able to say, hey, this is going to be a negative 9, because I'm going to subtract 18 from both sides and get this, and then I'm going to divide by 2, and a negative divided by a positive is a negative. And there's your answer without going into the complexities of quadratics. Alrighty, number 18. Cal crossed out n randomly selected days from the 7 consecutive days on the calendar. What's the minimum value of n that guarantees she crosses out 3 consecutive days? Alright, here we go. I'm just going to start over here on the left hand side. There is crossing out 1 day. I'm going to cross out another day. But I'm not going to cross out Tuesday because that would be 3 in a row. So I'm going to skip this one and go to Wednesday. I'm going to cross that one out. And then I'm going to cross this one out. But I'm not going to cross out Friday because that would be 3 in a row. But I am going to cross out this one right now. So far I've crossed out 5. I've crossed out 5 days without making 3 in a row. See? I don't have 3 in a row yet. But the minute that I cross out either Tuesday or Friday, I have 3 in a row. So the minute that I make the 6th mark out or cross out, I'm going to have 3 in a row. Alright. 19. Whoever wrote this problem, I'd like to buy him a candy bar because this is a really cool problem. We have defined operations, and we're taking squares and square roots, and we're adding and subtracting. But when I started this problem, I go, well, by golly, I notice these numbers here. I notice I have a 3 and a 4. Where have I seen 3 and 4 before? Well, those are the two legs in a 3, 4, 5 right triangle. Remember, leg, hypotenuse in a 3, 4, 5 right triangle. Oh, that's interesting. And then I came over here and said, well, wait a minute. There's 20 and 16. If I multiply these by a scale factor of 4, 3 times 4 is 12. That's 16. 5 times 4 is 20. And what do you know? There is the leg and the hypotenuse of another right triangle. Alright, so if I take this right here, this definition says that I'm going to take the first number, in this case 3 would be p, and I would get the square root of 3 squared plus 4 squared. And so we can do this following these definitions, but we go, well, hey, wait a minute. If this is talking about 3, 4, 5 right triangle, I don't have to go through all this rigmarole right here. I could just say all of this stuff is going to give me a 5. So looking over here, where I am subtracting, because we would always take the leg away from the hypotenuse when we're trying to find the missing side to a 3, 4, 5 right triangle that's been scaled with the scale factor of 4. So I can either plug the numbers in and go through all the rigmarole, or I could just notice that, hey, this one is going to be 12. You See how we can, if we recognize the patterns and we see how to piece this together. And so now, what do I notice here, which is even more cool? I was going to say cooler. I guess I could say cooler, because what I notice about 5 and 12. Oh, that's the two legs to another famous right triangle, the 5, 12, 13 right triangle. And I don't even have to do the rigmarole of putting the numbers in and crunching it and wasting time. While your competitor moves on to the next question, we're doing this. But if we stop and go, hey, wait a minute, these are just Pythagorean triples that Miss Malik asked me to memorize, you can get through this problem rather quickly. Oh, and by the way, I want to say on all these problems, there's more than one way of doing it. My way is not the only way. I never said that, never claimed it, never will claim it. So if you're able to get the answer in another way, God bless you. Let's celebrate it and go from there. All right, I'm going to show you this one two ways, and I think I'm going to be out of time. We can do the same thing as we did up here. We can do the unit conversion. I can show you that real quick. We've got 800 meters that we need to catch up, and we're traveling at a rate of 4 minutes. I need to do that. So if I get out of, notice I have kilometers per hour. I need to get out of meters, and I need to get out of minutes. So I can get out of minutes by doing a unit fraction with 60 minutes over an hour. So see, that's how minutes go away, or how time flies. Get it? Time flies. All right, so a kilometer, I know that there is 1 kilometer for every 1,000 meters. So the meters will go away, and I got 3 factors of 10 right here, so these 3 zeros will cancel this one and these 2 right here. And I know that 8 over 4 is 2, and 2 times 6 is 12, but that's not my answer. 12 kilometers per hour. What I need to do now is that I need to take the difference between that. And so 50 kilometers per hour minus 12 kilometers per hour is going to give me my answer of 38. Now I want to show you my way. This is the way the guy who did the solution key, that's the way he did it. I want to show you something else, and this will emphasize the distance formula. Let me get we know the answer is 38, but let me just show you this. We know the rate of speed, or you should know, the rate of speed multiplied by the time that someone is traveling is equal to the distance traveled. Okay, so R times T equals D. That's a generic formula you need to burn in your brain. So if I kind of make a little chart here real fast, because the bell is going to ring here shortly. I've got a car and a horse, right? So I know the rate of speed of the horse is 50 kilometers per hour, and I know that I have 4 minutes. Well, the thing about it is I need to get into hours. So 4 minutes, and if I divide that by 60, is 1/15 of an hour. So I'm going to put 1/15 here, because these two have to have the same unit of time. I can't put hours here and minutes here. It's not going to work. So if I do that, if I just say, oh, well, hey, it says that I'm going to multiply this. If I multiply this, what do I get? I get 50 over 15. Okay, so that's the distance. Now, do I know the speed of the car? No, that's the question. So I'm going to put a variable here. Do I know the time that it was traveling? Yes, I do. It was caught up in 4 minutes, so the time is going to be the same. So this is 1/15 of an hour. So if I multiply this together, what do I get? I get R over 15. Okay? Now, the problem that I made was that I forgot something because I was kind of panicking right here. All right? The horse has to make up an extra 800 meters. So this is not 50 over 15. This is 50 over 15 plus 0.8. All right? And I think I probably have messed this up because I was trying to go too fast. Let me double check. What do I have? Nope, I can't put that right here. Hang on just a second. So we have a distance for the horse right here. All right. I think that'll work better. I'm sorry. So distance that the horse needs to travel needs to make up 0.8 of a kilometer. Again, I got to go with the kilometers. Remember, 800 meters is 0.8 kilometers. Told you. All right, so I'm going to take the horse thing. I'm going to multiply these together and get 50 over 15 is equal to the distance of the horse plus 0.8. 0.8 is 4/5 or, yeah, wait for it, 12/15 because I need a common denominator. So if I solve for the distance of the horse, I'm going to subtract 12/15 from both sides. And all that Saxon math should be coming back to you now, right? So the distance of the horse is 50 minus 12, which is 38 over 15. So take these two things right here. The distances have to be equal. If you're going to catch someone who has a head start, your distances will ultimately be equal. And I really don't need this step, but I'm going to do it anyway. What's R equal to? Well, if your denominators are the same, in a proportion, your numerators have to be the same as well. Hey, look at that. I got 38. Anyway, my time is up. The last problems are fairly hard, so I'm going to study those and get back with you. Until next time, remember edpuzzle.com, go to the website and join and put your answers in, and I'll grade them and I'll let you know if you got them right or not. Bye.